If you have been studying the literature about calculus, it is everywhere, in different texts, even online, that the derivative, if y rather, is equal to log to base e of x, then the derivative of y with respect to x is simply 1 over x. So, for some students, they just memorize this, and then if you ask them, how did you come about this, they will be looking at you. Some just say, oh, that is how we saw it. One of us will tell you, this is what it is. For the first timers, they will struggle and always remember this and say, oh, dy by dx is 1 over x. So they memorize that and they use it. Of course, it is correct. Dy by dx is 1 over x. But an interesting thing to do is to verify that actually if y is log to base e of x, then the derivative of y with respect to x is 1 over x. And so this is what we want to learn now, so that you can easily beat your chest after watching the video and say, I understand how to show that if y is this, then the derivative of y with respect to x is 1 divided by x. Of course, here x is different from 0, x is different from 0, so this makes sense. So what we are trying to learn is differentiation of logarithmic function. So that's the topic, Now let's take y to be log to base e of x. The problem is I'll put it such that it will sink well in our minds, arising from what we've learned. Find dy by dx from the first principle. That means apply naturally the definition of derivative and get what dy by dx is. So that's what we mean by first principle. Of course, you're familiar with that. If you have been watching this video, you will be familiar with this. If you have not, please go to the beginning of the videos on calculus, and then you stumble at how I define this, and we have applied it several times. Okay. So let's get the job done. If y is log to base e of x, then y plus small change in y is nothing but logarithm to base e of x plus small change in x. Let me call this equation number 2, and I call this one equation number 1. Okay, so a small change in x will cause a small change in y. We want to make change in y the subject of the equation. So if we subtract 1 from 2, so I have 2 minus 1, will give you on the left hand side y plus dy minus y is equal to, on the right hand side, I'm going to get log to base e x plus change in x minus logarithm to base e of x. So this is what we have. Y minus y is 0. So what we are left with on the left hand side is change in y is equal to log to base e x plus change in x minus log to base e of x. We are familiar with the laws of logarithm. One of them says that log to base e of a, minus log to base e of b, where a and b are numbers, is nothing but log to base e of a divided by b, because provided b is not 0. We're going to apply that here. And so if we apply this here, this will give me log to base e. Here, this is independent of whether the base is e or not. here this is the Napierian logarithm. So it is to any base. This law is true. Okay. So we can write this as log to base e of x plus change in x divided by x. This is no other person than log to base e of 1 plus change in x divided by x. So this is what we're going to get by simplifying this. Alright. If I divide change in y by change in x, what I'm going to get is 1 divided by change in x log to base e of 1 plus change in x divided by x. Because I simply divide both sides by changing x here and then changing x there. Okay. This is nothing but 1 divided by x times x divided by change in x log to base e 1 plus change in x divided by x. Because x will divide x to give me 1. 1 multiplied by any number is that number. So I have just made a simple manipulation here, but I have not changed the original equation, the original number. So 1 over x, 1 over change in x can be written as 1 over x times x over change in x, because x will cancel x to give me 1. 1 times this will return what I have. So this and this are the same. Okay? Alright. But then we know again that if I have u log to any base of say z, maybe to base a, this is the same as log of z raised to power u to base a. We are familiar with this, so we apply that here. And so this is nothing but 1 over x log to base e of 1 plus change in x divided by x raised to power x divided by change in x. Okay. Now, if we set n to be x over change in x, then as x tends to 0, n will tend to plus infinity. This is true because as change in x tends to 0, x over change in x tends to plus infinity. If you have watched my previous videos on infinite limits, you would have encountered an expression of this form because we treated infinite limits in some of the videos. If you are not familiar, please, you can go back on limit of functions and you'll be able to see why as x change in x tends to 0, then n, which is equal to this, will tend to plus infinity. We dealt with that under videos on limit of functions. So with this in mind now, we continue our discussion. So this expression now, in terms of n, we now have that dy by dx is nothing but 1 over x log to base e of 1 plus 1 over n, because my n is x over change in x, meaning the reciprocal of n is what I have here, and that is 1 over n, now raised to power n. It is a standard knowledge. If you don't know it, don't bother, because still a beginning session. So I'll tell you what this is and then you use it as you progress. We know that limit as n tends to plus infinity of 1 plus 1 over n raised to power n is exactly e, the Euler's number. So this is that. Therefore, what I have here, if I pass limit, is what is going to be reflected by this. Also remember that we said that dy by dx is nothing but limit as change in x tends to 0. of change in y by change in x. Is done. So, but then as dx tends to 0, it means n tends to infinity as we have said there.